Hi everybody. So last time we introduced one of our first electrical components, which was a battery. And I've got here a standard 9-volt battery. You can see the 9 volts is labeled clearly on the battery itself. And it has these two terminals here. And if you turn the battery, you can see one is labeled as the negative terminal, and the other is labeled as the positive terminal. So we've got the positive and the negative terminals of the battery. And you'll recall that the positive terminal, this is where there's an excess amount of positive charges, and the negative terminal, there's an excess of negative charges. The next components that I want to show you are the wires. So this particular wire is what we might call an alligator cable because the tip of it is kind of like an alligator, and it kind of can pinch onto things. And a wire is composed of a conductor. In this case, it's probably a piece of copper that's surrounded by a plastic jacket. And the point of this is that the copper, being a conductor, allows electricity or electrons, charges, to flow through it, whereas the plastic on the outside is an insulator, and so keeps those charges inside the wire. Of course, you have the metal exposed on either ends so that I can make connections to different things. There are also different colored wires, so I've got a black wire here. A lot of times you use the colors to help keep things organized in your circuits. So many times red wires are used for positive connections and black wires are used for negative connections. There are, of course, though, many different conventions used. Sometimes you'll see green for negative or white for positive and various things. But red and black are fairly common. I'll try to follow those conventions as often as I can. The next thing I have here is a standard incandescent light bulb. And the way an incandescent light bulb works is as current flows through it, that current encounters a resistance in the light bulb. And as the current flows through that light bulb, through the resistance in the light bulb, it heats up and gets hot. And as it gets hot, it starts to glow and light up. So I'm going to wire this up and show you the circuit that I just sketched in the last video, and see how it can power a light bulb. Okay, so now I have hooked up the battery to the light bulb. You'll see I've got the red wire clipped on to the positive terminal, and then the other end of the wire connected to one end of the light bulb. I've got the black wire connected to the negative terminal, and the other end hooked up to the other end of the light bulb. So again, if we think about conventional current as the flow of positive charges, we'll have positive charges from the positive terminal are going to flow through this wire, through the light bulb, and then back around to the negative side of the battery. As those charges flow through the light bulb in particular, there's going to be some resistance in the light bulb that's going to slow that current down and prevent just very, very high amounts of current flowing from the battery. And as that current is slowed down, it'll tend to heat the filament of the light bulb up, and when it's heated up, that will make it glow. So this is the real life example of the circuit that I drew for you on the board in the last video. In the next video, I'm going to show you another type of light called an LED, and how you can, instead of making this circuit where everything's sort of dangling out in free space, I'll show you how we can simplify things so that it's a little bit more compact and a little bit of a neater looking circuit.